Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is minimum polling path sum. Okay, so problem statement goes like this: you will be given an n cross n matrix, okay, with the name grid, and you have to return the minimum sum of polling path with non-zero shifts. Okay, so definition of minimum sum polling of a falling path with non-zero shift is given below. A falling path with non-zero shifts is a choice of exactly one element from each row, such that no two elements chosen in adjacent rows are in same column. Okay, so the definition is pretty straightforward. What the problem statement is saying is a falling path is a path. Okay, I yeah, now it's visible. So we will be picking one element from each row from, if let's say these are rows and these are columns, which one element from each row, such that no two elements are from same of adjacent rows are from same column. It means if you picked one, you cannot pick four. You can pick any of the elements in the below row except four, because this column is cannot be used for the adjacent row, so you can pick these two. It is entirely dependent on you how what you will pick, except the previous column that was chosen for the element. Okay, and if let's say I decide to pick 5, then except this column I can pick any element from the below row. So I can pick 7 or 9, so it is entirely up to me what I pick. Okay, so let's see the constraints before thinking of an approach. So the single side of the grid, or number of rows and number of columns, both will be of order 200, and each entry in this grid is ranging from minus 99 to 99. Okay, so these are the constraints. Now let's think of an approach. A brute force approach will be to try out all the combinations. Okay, so in order to try out all combinations, for each row you will be having, for the very first row you will be having n choices, since there is no previous row. Then for the below row you will be able to pick from n minus 1 columns, except the column that you picked the element from the first row, so n into n minus 1. Then for this particular row again there will be n minus 1 choices, so overall you can say it will be around order of n. Okay, just a loose upper bound. And also you will be doing this n minus 1 into n minus 1 kind of thing for how many number of times? For row number of times. Row is again n. Okay, so all in all a loose upper bound can be around n raised to power n. Okay, and you will see that the as per the constraints it was 200 raised to power 200 something. Okay, and this will be the whole order of, or number of operations required, order of number of operations required. Okay, ops required you can say, for our brute force solution. Okay, of trying out all the combinations. But there is an operation limit in order to get your solution accepted, that operation limit is 10 raised to power 8 ops. So if the number of operations required from your side is going beyond this limit, or reaching equal to it, then you might get a TLE and your solution may not be accepted. So in order to get your solution accepted, you have to stay below this limit. Okay, so we will try to achieve that. Instead of trying out all the combinations, we will think something optimal. Okay, so what we will be doing is, let me clear the board a little bit. Okay, this is row and this is column. So we will still be picking elements from each row. uh Basically we will be visiting each cell one by one. Okay, visiting each cell one by one, and then we will be having a 2D array similar to grid. Okay, so if you are at this particular cell, then which of the cells in the previous row will contribute to the, you know, will be the cell that if you pick that cell, it will be minimum, it will result in minimum sum. Okay, so 5 is fixed. You have to pick one of the columns which is having minimum. Okay, so how to do it? You cannot for sure pick from the same column. Okay, that is one thing. And you will be picking from all, you will check out all the columns that are having minimum value in them. So minimum value happens to be 3. Okay, so 5 plus 3, which will be by the way 8. Okay, and so for each of the and then this 8 value will be replaced in will be replacing this 5 value. Okay, or you can have another structure created and use that instead. Okay, so let me take the code here so that you will get a perspective in a better way how things are working out. So, or let's quickly go to the code. I think if we arrange both of these in a single slide, then it will be beneficial. So let's do that. This is the code that was required. Okay, and yeah, and let's quickly copy that image also. Yeah, so for the very first row there will be no previous rows. So this sum state is a n cross n matrix that we will be using to store what is the minimum sum that is possible if we are ending our search on this particular cell. Okay, so each cell will be having the minimum sum possible for that particular cell. Okay, let me write it. Each cell will have minimum possible sum that it can have, or minimum falling path sum. Okay, minimum possible falling path with what they call it, I think non-zero shift or something. Yeah, with non-zero shifts, minimum path with falling path with non-zero shifts. Okay, if this falling path with non-zero shifts is going to end at this particular cell, then this cell will be having that the sum of the whole path. Okay, so this is what I am trying to tell you, that each cell will be containing this in this sum state grid or 2D array that we will be making. It will be in same dimensions of n cross n. Okay, because the number of rows and number of columns are equal to n here, they both are same. So just to for 5, instead of 5 we will be, or you can have a corresponding grid. So for very first row, this condition will not be true. Okay, so you will visit all the entries in this particular grid one by one. Since the first row is not having any previous rows, so some state will anyways be having values of that row only. So let's quickly copy the first row 1, 2 and 3. Then for the subsequent rows, they will have some previous rows. This condition will hold true, and we will be picking the minimum possible sum state for the contribution from the previous row. Okay, so if we are at 5, then we want minimum contribution from previous row. Okay, minimum contribution from previous row. So for that, except the column which 5 is at, we will be searching for all the previous row columns. Okay, and we will be picking minimum sum state uh cell, okay, from previous row. So once we have that, we will check. Basically this int max value is for avoiding the situations where we cannot have a previous contribution. So if your minimum contribution value is not equal to int max, it means you are having some previous contribution for some state. Then you will add that value to your current sum state for current cell. Okay, and where the answers for this problem will be stored, they will be stored in this particular row. In this particular row, the last row, whatever will be the minimum value will be our answer. In which grid? In the sum state grid. Okay, so this is what we are doing here. Okay, and as far as time complexity or the number of operations are concerned, so this loop will take order of 200. This will again take so you can say 200 operations. Okay, and this one is again 200 operations. So basically it is 2 raised to power 3 into 10 into raised to power 3. Okay, so basically it's 8 into 10 raised to power 6, which is still less than 10 raised to power 8 operation limit. So your solution will be getting accepted, you need not to worry about that. Okay, and this is the whole logic and how we will be solving it. And I would like to mention that it would have been possible to not create this sum state. We could have used the grid also for storing the values, but just to make it clear to you that how things are going on, I decided to use some extra space. And space complexity wise, as you must have guessed, it will be n into n. Okay, and time complexity wise, you can say that this is space complexity, so order of n square. And time complexity wise, you can call it order of n cube. Okay, where n is the number of rows and columns. Okay, so this is the whole approach. This is the solution. If you are still having any doubts or any queries in general, then you may ask them in the comment section. And by the way, for those of you who are wondering what kind of approach we just used, it is dynamic programming. Okay, and basically whoever is new to this concept, I will provide link of an article describing what dynamic programming is. Basically it's just as you just observed that it's just optimization over brute force. uh it it involves two things. If we briefly talk about it, first of all, you store your previous results into some structure, and then use those previous results instead of visiting each state again and again. Okay, so this is essentially what dynamic programming is in nutshell. So this is what we were doing. If you observe that the sum state was storing nothing but the previous results. Okay, so let's consider a scenario that there are two paths. One is this path, yellow path, and let's consider another path, that is this red path, starting from here 3 5 and then 7. Now you may see that 5 is still, you know, common in these two. So you will be doing calculations for the 5 two times. So basically it's just like that. If let's say I decide to pick a path of A, B and C, and then D and E. Okay, and then there is another path A, B, C, then G and H. Okay, so this part is matching in both of the combinations. Let's call this combination 1 and combination 2. So we will still be again doing calculations for this path. So why do calculations again and again? Just memorize this particular result and then use that result instead. So this is the whole idea behind dynamic programming. Okay, and I hope this problem solving session and this solution walkthrough provided some or added some value to your journey of owning your DSA skills. And remember that consistent practice is the only way to master DSA. Till then, I will see you in the next video. Till then, keep solving problems, and thank you for watching.